kayo na perform ng experiment na wala naman palang silbi doon sa gusto nyong makuha na method. Okay? That includes also sampling, pre-treatment or conditioning of the samples. Okay? Whatever your sample is. It could be environmental sample, soil sample, water sample, blood sample, urine, whatever sample that you are given. Okay? Kailangan siya pre-treat and condition. Okay? Most of the time, kailangan lagyan pa ng mga binders and so on before you could do your experiment. So, again, once you have your sample, kailangan mo siyang i-pre-treat or condition. For example, if you take blood samples, usually nilalagyan ng anticoagulant para hindi siya mag-coagulate. Tama? That is part of pre-treatment and conditioning. Follow so far? Okay lang? Next is either you do a qualitative analysis or a quantitative analysis. In qualitative analysis, syempre you are looking at observed characteristics of your samples. The quality of the samples, the color, consistency, texture, if you must. No? Those are qualities of substances that you can analyze, qualitative or quantitative. Obviously, if you say quantitative analysis, you are now looking at how much of a particular substance is present in the sample. That is a quantitative analysis. Okay, how much volume, how much weight is present of that particular substance in your sample. And then, of course, as part of your job, you have to give a report or a certification that indeed you have analyzed the sample given to you. No? Just like in any other laboratory, halimbawa, nagpa-check ka ng urine, no, sa laboratory, syempre, after a while, after the analysis, you will be given a report, no, that indicates whether or not you have substances that should not be present in your urine, for example, or if the substances present in your urine is out of the ordinary in terms of the quality or the quantity. Okay, so you have a report. And then, obviously, kailangan mo i-review yung problem mo, whether or not yun ba yung pinakita sa'yo. Now, in a normal setting, in a real-life setting, obviously, nagiging routine ang mga analysis. Right? Nagiging routine na yon. So, pag halimbawa, binigyan sila, pag nagpakuha ka o blood sample, no? Tapos complete hematological analysis. So, automatically, meron ng protocol ang laboratory that you will just follow. Tama? In those cases, you don't really need to review the original problem because in the first place, if you're given a particular sample, you already have you already know what to do with the sample. Okay? Any comments so far? Question? Wala? Okay lang? Sige. So again, this is part of analytical procedures. Okay? Now, again, all of these things in the checklist here, usually, if you're doing it every day, will just be some sort of parang routinary work, no? So you don't really need to know or validate your technique because you already know what the technique is, right? Okay, so can you read this? Is it too small? Okay lang ba? Or palakihan natin?
Okay lang po,
So
sir.
these are sample or the types of techniques, no, that are used to analyze chemical or physicochemical processes in the laboratory. Okay? So you have here, okay, let's try to zoom it out, zoom it in. Wait. Okay. So you have here your technique, the property measured, what are you trying to measure, and the principal areas of application. So are you familiar with these terms already?
Papo, sir.
Are you familiar or not yet?
Not yet, sir.
Not yet po, sir.
Okay. So you have here gravimetry, titrimetry, spectro, electrophoresis and chromatography, thermal analysis, electro and radiochemical analysis. Okay, when you say gravimetry technique, you're using gravity, of course. That's why the term is gravimetry. Here, you're trying to measure the weight or the mass of pure analyte or compound of a known stoichiometry. By the way, what is stoichiometry? Ano nga yung stoichiometry? Anyone? Yes, anyone? Earl, yes, Earl.
Good afternoon, sir. So, I define stoichiometry as a section of chemistry that involves
Hi, good
the,
afternoon, yes.
the reactants or products in relation to chemical reaction to determine the desired quantitative data po, sir.
Okay, so basically it's um, relationship, no, looking at the relationship between reactants, right, of a chemical reaction, no, and the products of that, and you want to know what is the quantity of the thing that you want to achieve. Okay, so stoichiometry on. Okay, so when you talk about chemical properties and uh, uh, how the reactants would relate to each other to form the product. That's stoichiometry. No? So it's either pure analyte meaning wala siyang ibang nakahalo sa mixture, or compound. Okay, so gravimetry application is to quantify major or minor components of substances. That's gravimetry. Okay, sa titrimetry, no, titration techniques, you are here, you want to know the volume naman of the reagent solution that reacts with the analyte. Have you done titration in the lab? For example, if you want to convert an acid into a base, you put, let's say, hydrochloric acid into the mixture, and then you want to know how much volume of the acid that you need for the mixture to become neutral, for example, or for the mixture to become acidic. That's titration. So you are using here in titration a Buray, and then you will drop your reagent slowly, drop by drop, and then measure how much you use in terms of volume to analyze how much of the analyte is present. Okay? So basically, if you talk about gravimetry and titration, sa titration, you want to know the volume of the reagent or the analyte, while sa gravimetry, you want to know the weight in grams usually of your compound or component to be analyzed. Okay, both of them are used to identify or quantify components of a mixture. Okay, gravimetry and titration method. Next is spectrometry. Spectrometry. So when you talk about spectrometry, you are using here wavelengths, usually wavelengths of light, to analyze naman how much substance is present in a particular compound or mixture. No? So you have here two different types. You have atomic and molecular spectrometry, which measures the wavelength and intensity of the radiation emitted and absorbed by the analyte. So basically, parang ganito yung spektro. Imagine meron kang glass of water, a glass, let's say yung clear glass. So kung meron kang clear na baso, okay, glass. And then you put, let's say, pure water there. You put clear water there, pure water na clear, and then you light on one side a flashlight. How much of the light do you think would pass through the other side of the glass? Na tumatama doon sa liquid sa loob. Marami ba or konti lang? Question? What do you think? Imagine meron kang baso na clear, na glass, lagyan mo ng tubig, tapos maglagay ka ng flashlight dito, i-on mo yung flashlight. Marami ba ang light na magpapass through doon sa water? Can you still see the light that in the other side of the glass?
Yes, sir.
Mariel?
Yes po. Ano po, sir? Kundi na lang po yung light, sir, na mag-reflect.
Konti na lang ang light or marami ang light na mag-pass through doon sa glass na clear? Sorry, Mariel, medyo putol yung ano mo. Who else? Jinli? What do you think will happen?
Madami pa pong
Marami bang
light,
light
sir,
na mag-pass through
pero
doon
parang
sa water?
pero
Through the glass?
dispersed na siya. Opo.
Pero hindi lahat. Is that what you're saying? Okay, sige.
Ano,
So, marami pero dispersed.
dispersed na po
Okay,
yung
tama.
light, sir.
Tama
Hindi na
naman.
po siya.
Okay. Now, imagine, instead of just pure water, you try to put, let's say, kanang coffee powder. So, syempre, pag nilagyan mo na ng kape, medyo marami nang ma-dissolve na substance doon sa tubig. And the water now is not that clear. It will become darker, no? Depending on how much coffee you infuse in the water, right? Now, if you put again the same flashlight on one side of the glass, most likely, the amount of light that will pass through the glass is less compared to that of the clear water lang ang present. Do you agree? Okay, thank you. So if that's the case, we say that the light that passed through that of the glass with coffee in it is less compared to that of clear water. So ang ibang light na galing dun sa flashlight ay na-absorb nung tubig na may kape. Tama? And in that case, if you compare it to clear water, you will relatively know that there are more substances present in that glass with coffee compared to that glass with water. Okay? That is the concept of spectrometry. Okay? That's the concept of spectrometry. The problem, the thing with spectrometry is you only have very small amount of analyte, a few drops even. no? And then ang pwede mong makuha na information from spectrometry is that because different substances would absorb the light differently, would absorb wavelength and intensity of light differently, you could read kung gaano karami ang nawala na light, na absorb na light doon sa substance mo, and it could correspond to a particular substance. Okay? That's why, aside from qualitatively and quantitatively measuring the analyte in your substance, you could also actually identify the analyte itself based on how, huh? So that's atomic molecular spectrometry, and also you have mass spectrometry. In this case, you are trying to analyze the mass, no? How much of the matter is present. Okay, so these spectrometric analysis would be for qualitative, quantitative, and structural identification of substances. Question so far? Dito sa school, meron tayong UV-vis spectrometer. One of these days, I hope we can use that. No? Meron tayo dito at dalawa, pero hindi pa nagagamit. Hindi ko alam. Pero we will try to use that in this subject sa laboratory natin. Okay, you also have here chromatography and electrophoresis. Now, chromatography and electrophoresis are techniques that are used to separate substances. No? These are used to separate substances in a mixture. Okay, the very simple form of chromatography is paper chromatography. I'm pretty sure you've done this in the lab in high school. No? Yung meron kang filter paper, tapos lagyan mo ng alcohol, ipa-absorb mo yung alcohol, pero yung filter paper mo, lagyan mo ng ink. Let's say, lagyan mo ng ink ng ballpen mo, tapos as the parang ganito siya. So, imagine meron kang paper, filter paper, no? Isang strip ng filter paper, tapos lagyan mo siya ng ink dito na part, maglagay ka ng ink, blot ng ink, and then you put that inside a container na may alcohol. So you would assume na yung alcohol ay aangat, di ba? I-absorb siya ng paper paakyat. Can you still hear me?
Yes po.
Can you still hear me? Maingay ba?
Yes po, sir.
Hello?
Marinig ko po, sir.
Okay, sige. I can see you kasi. So I'm not sure if you're still there. Anyway. So again, what I'm saying is, let's say you have a filter paper, a strip, and then you put alcohol in it, tapos ipa-absorb mo siya, i-dip mo ang isang dulo sa alcohol, the alcohol will be absorbed slowly upwards, blah, blah, blah. And as the alcohol travels upward, the contents, the components, the component colors of that ink will be dispersed. And now you have distributed or you have separated the substances in the ink. That is one form of chromatography. Okay? In terms of electrophoresis, it's a machine, no, a technique that is used to separate naman DNA strands, no? Or protein components, no? Protein mixture, okay, using electricity. That's why it's called electrophoresis, okay? And another is thermal analysis used to uh, characterize mixture, no? Wait, please. And then you have electrochemical analysis and radiochemical analysis. So if you look at the principal areas of application, most of the time, these are for qualitative and quantitative analysis of components, of substances in a mixture, or what we call analyte. An analyte is the substance that you're trying to analyze. Okay? Any question? Okay, if there's none, let's continue. Okay, so let's proceed now to the different set of steps, okay, in analyzing chemical substances. Okay, so you have here a list of things that you would consider if you're doing an analysis. So as mentioned earlier, the first part should be to know your problem. So in this case, you have to know your purpose, no? The time scale, and the cost constraints of your analysis. Now, why do you have to consider time scale? Okay. Sometimes your analytes are very sensitive in such a way that if you will leave your analyte for an extended period of time, you will no longer get the proper analysis. So you have to consider the window of opportunity for you to analyze your sample. Okay? Kaya nga yung ibang sample kailangan i-pre-treat mo or i-precondition. Yung iba kailangan mong ilagay sa ice, yung iba kailangan mong i-thaw, ang iba kailangan mong ibalot, hindi siya kailangan sinagan ng light. No? So there are things that you consider because these are the things that will make you have a wrong conclusion or might give you false negative or a false positive result. Okay? So the accuracy of your measurement is also hampered if you will not consider your time scale, required time scale of that particular experiment. Okay? And also the cost constraints. Cost in terms of monetary cost. Okay? Sometimes, if you run a particular machine, no? Let's say, kaya niyang mag-run ng 12 samples. Okay? Pero ang sample mo isa lang. Pag ni-run mo ang isang sample, gagamit ka pa rin ng the same amount of reactants, no? Para sa 12. So kung ikaw, negosyante ka, you have also to consider that particular constraint. You follow? Ako ninyo? Para ba, kung magluto ka o rice, sa rice cooker, halos the same lang ang magasto nimo ng kuryente pag nagluto ka ng 1 cup of rice sa 4 cups of rice. Hindi masyadong malayo ang gastos. So, mas mabuti ba, magluto ka na ng marami para isa lang kagastusan. No? Parang ganon. Cost constraint. Next is level of analyte expected and detection limit required. Gaano ba kalaki or kaliit ang limit ng detection ng machine mo, for example? Some machine can detect, let's say, up to just 100 parts per million. No, halimbawa, you're trying to check whether or not the sample, your analyte has substance X. Okay, substance X, present, absent. No, or presence, absence. Is substance X present or absent in your sample? Now, your machine can only detect up to at least, at the minimum, 100 parts per million of that substance X in a sample. Okay? Now, in that case, if let's say your substance is only, let's say, 50 parts per million, hindi yun kayang i-detect nung machine mo. Kasi nga, ang minimum niya na kayang i-detect 100 parts per million. Okay? You follow? May question ba? Comment? Question? Can you still hear me?
Opo, sir.
Okay, anyway, what I'm saying is, if you have to know the limit of your machine, no? Kasi in that case, no, the scenario that I gave you, you would say that your substance does not contain substance X. And if you say that, that means you have a false negative result. Kasi, andun naman siya, hindi mo lang kayang i-detect. Nakuha? Kaya, di ba, pag humihingi kayo ng samples, meron kayong minimum amount na kailangang makuha na sample, no? To make sure na you have enough sample para magkaroon ng replicates. Okay? What else? You also have to consider the nature of the sample, the amount, and how much of the sample is needed for the procedure. Pag nagpa-fecalysis ka, ano yung fecalysis? Di ba mag-check ka sa imong fecal matter? No? Pag mag-fecalysis ka, kailangan mo ihatag sa sample sa isa ka garapon? Or doon lang sa maliit na container? Hindi naman kailangan marami. No? Pero kailangan may enough. Okay? So you have to also know how much do you really require of the sample. No? Okay, next is accuracy required for quantitative analysis. No? So dito sa accuracy, well, most of the time, if you are in the laboratory, you will be briefed on how accurate your machine is. So that's why for reporting purposes, di ba meron tayong standard deviation? No? You have standard deviation to measure, because you are not clearly 100% sure that your measurement is accurate. Halimbawa, ang measurement mo is 100 cells plus and minus 5. Ano ibig sabihin nun? In that case, pag sinabi mo 100 plus and minus 5, no, your range would be from 95 to 105. So it could be from 95 to 105. Okay? So meron kang range sa error mo. Okay? Because you are not sure, or you are not 100% accurate sa inyong measurement. Although it will give you enough information naman. What else? Availability of reference materials standards, chemicals, solvents. No? This is important because sometimes you need standard reference materials to compare your result. Halimbawa, simple lang yan ay yung pH. Di ba? Have you tried using pH paper sa chemistry dati? Nakagamit na ba kayo ng pH paper? Alam ito, na-color-color siya na strip. Have you tried that? Yes or no?
Wala pa po.
Wala, okay. So, meron siyang maliit lang na strip, no? A very small strip of paper na meron siyang color. Yun yung standard reference material mo. Tapos, you will be given a strip of pH paper, and then you will dip that to your liquid sample, and then you do it like this. No, i-fanning mo siya sa mag-dry up siya ng konti, and then you will notice that the strip will change its color. So, how will you know the pH of your substance? You will compare that color to our standard reference material. Kung saan color ito, halimbawa, kung pH 1 to 14, no? Ano ang color ng pH 6? So, pag nagtapat yung color ng sample mo doon sa standard reference mo, edi yun yung pH. Okay? Follow so far? Now, if you have machines that are quite powerful, no? Sometimes ang machine mismo meron na siyang pre-loaded information of reference material. Siya na mismo, ang computer ng machine na ang magsasabi sa iyo kung ano ang substance or gaano karami ang substance nandoon sa sample mo. Okay? So, these things are important if you are trying to analyze chemical samples. These are, you could say, parang mga general information or general considerations in doing analysis like this, which are, kumbaga, as I said earlier, if you are doing this every day, you won't even try to bother with these things already. Kasi kapang-kapa mo na. No? It's just like when you are starting to learn how to cook. No? Tapos you're using, let's say, a reference. Let's say a cookbook. No? How much of this ingredient is needed to create one particular dish, something like that. No? If you're doing it over and over again, you won't even try to measure your components already. No? Itsan-tsan lang mo. Okay? The problem with that is the accuracy. No? That's why kung sa karinderya ka magkaon, sometimes medyo ngayong araw medyo maalat, bukas medyo tama lang, or napasubraan na po sa kaaslom na, because they don't use standard measurements. Do you agree? Pero pagka you eat, let's say, in Jollibee or in McDo, no? The way they do things is very quantified in such a way that whether you eat in Jollibee Jensen, Jollibee in Manila, or Jollibee in Los Angeles, you would taste the same thing because they are using the same amount of ingredients in one batch, right? Any question? And of course, lastly is quality control and safety factors. No? Quality and control is very important, and it is usually done. Quality assurance, quality control is usually given the job given to the most senior of the technicians, right? Kasi siya yung may alam ng siya ang may maraming experience sa paggawa ng mga bagay-bagay. Any comment, question? Wala? Are you still there?
Yes, sir.
Po, sir.
Yes po.
Yes, sir.
Okay, so next. Anong oras pa tayo mag-end?
2:30
po.
po.
2:30 po.
1:30, 2:30 ba?
Yes po.
2:30 or 3? 2:30? I think it's 2:30. Okay, so we still have 20 minutes. Let's continue. Now, next is method validation. No? Method validation. A process where an analytical method is checked for the reliability in terms of accuracy, reproducibility, and robustness. Okay? Again, in the real life setting, every now and then, the laboratory technicians should always calibrate, for example, the machine that they're using. Tama? When you say calibration, kumbaga, let's say, gumagamit kayo ng pipette. Kanang pipette nimo, have you used a micropipette before? Sa lab? Naka-micropipette na kayo? Wala pa? Micropipette? Wala pa? Okay. So, kanang micropipette, it's, usual naman siya sa lab, pero if you're using it over and over again every day, for example, no, yung accuracy ng measurement niya nawawala. So, it's depending on the manufacturer's protocol, yung kung sino ang nag-manufacture ng brand ng mic ng pipette nyo, pwede nilang sabihin na, let's say, if you're using it every day, you have to calibrate it every 3 months, for example. Remember, in the laboratory, guys, you are not using large amounts of samples. No, you're using microliters, not 1 liter, microliters, a few drops of a substance to be analyzed. Okay, and it's very important for you to have a very accurate measurements. No, so it follows that your instrument should also be very accurate, no? As accurate as it can be all the time. Okay? Because it will spell failure or success in your experiments or in your analysis. No? Pag sobra or kulang yung nalagay ninyo, halimbawa, sinet nyo ang tool nyo for, let's say, micropipette for 20 microliters. 20 microliters, kasi may mga numbers yan. Sige, lagay mo, 20 microliters. Kumuha ka ng sample. You would assume na 20 microliters na yon. Yun pala, 15 lang, kaya dili na siya accurate. Ang suction power niya, marumi na siya, maraming alikabok, whatever. No? Tapos, after the experiment, sinabi mo na ito yung result. Yun pala, hindi yun accurate. Okay? So, one way to be sure that your test, your analysis are always reliable, accurate, reproducible. Ibig sabihin, kahit ilang beses mong ulit-ulitin, the same ang result, and robust. Robust meaning the data is strong enough, very strong, umaga, no, reliable. You have to do validations of your methods. Okay? Let me blow this up. Okay, so here are some steps in method validation. Okay, can you read this? Nababasa naman, di ba?
Yes, sir.
Yes, sir.
Okay, so step 1 in validating your methods is performance characteristics of detector for single analyte calibration standards. No? So you have to know whether or not your detector, no, sa machine ninyo, kung ano man ang i-detect niya, is at par with the calibration standard. Nakuha nyo? Paano ba yung calibration na sinasabi? Okay. Halimbawa, pag nagpapalit ko mag soft drinks sa market, let's say sa supermarket, di ba nakatayo yung mga bote ng soft drinks? No? Imagine niyo ka na magtungo sa tindahan tapos na-ref sa or Pepsi. Tapos gipatindog dito ang mga bote-bote. Okay. If you notice, lahat pa sila, halimbawa, ng volume ng soft drinks, or may iba na mas konti, may iba na mas marami. Most of the time, hindi yung pantay-pantay. Okay? Kasi sinabi namin ng ginagawa ng machine, sometimes nawawala yung, hindi na siya nagiging calibrated. Follow? Okay? So, halimbawa, bumili ka ng 1 liter ng tubig, Nature Spring, o ganon. 1 liter na bote, na sealed pa siya, bagong gawa. Okay. Are you sure na yan ay 100,000 ml exact? Hindi. You are just hoping na tama ang measurement nila. Kay machine man ang di ba, ang mga bote ana mag-agi lang sa conveyor belt, tapos may mga nozzle lang na mag-fill in ng liquid. Sunod. No? And there will be errors there. No? So most likely, that's not 1,000 ml. It could be 900, 975, or 1,000.01. No? Sobra or kulang ng 1 liter. Okay? Pero meron tayong tinatawag na acceptable error. Acceptable error. Ibig sabihin, may accepted lang na error. Halimbawa, pwede siya ng hindi 1,000 ml, pero dapat it should not be less than, let's say, 990 ml. So, bisan pag 991, okay lang. 995, okay lang. Hindi rin siya pwede sumobra ng 1,010 ml. So, anywhere from 990 to 1,10 ml is okay. Ganun siya. So you have to know that if your detector should be calibrated, no, based on the standard. Is your so if okay ito, no, the performance characteristic of detector for single analyte is at standard, no? Pag sinabi mong single analyte, pag isa lang, pure lang imong analyte, no? Tapos tama iyang pag-detect, okay ka sa step 1. The next thing that you have to test is if your machine is also calibrated for mixed analyte. No? Paano pag different substance na, mixture na? The same pa rin ba ang accuracy niya, calibration niya? Pag yes, you continue. Process repeated for analyte calibration standards with possible interfering substance and for reagent bank. So, kailangan, okay, parang ganito guys. Let's say meron kang substance A. Na-detect ba ang substance A ng machine mo in the right amount? Pag okay, you pass step 1. Isa lang analyte, substance A. Sa step 2, ma-detect ba niya pag substance A, B, C, sabay? Pag ma-detect niya in proper amount, then you check step 2. So after step 2, you proceed to step 3. So aside from the A, B, C, you also will try to put interfering substances, yung mga kumbaga, paggulo lang na substance, halimbawa, A, B, C, lagyan mo ng F. Okay? Yung F ay mga ano lang, anong tawag dyan? Contaminant, for example. Lagyan mo ng contaminant. Will it detect the contaminant? Pag kaya niya ring i-detect ang contaminant, okay pa rin yun. So you proceed to step 4. Calibration naman with anticipated matrix to evaluate matrix interference. Now, if you look at all of these steps, basically, you are just trying to test ang iyong instrument, no? Kung kaya ba niya mag-detect ng isa lang or multiple substances at the same time, and if it can, aside from detecting your substance of interest, can it also detect the interfering substances or mga contaminants? If not, you have to go back to the different steps. That's why in this flow chart, if you answered yes to number 1, you proceed to number 2. If you answered yes to number 2, proceed to 3. If not, you go back to 1 and so on. Okay? So method validation. This is used again for you to know or for you to say that your analysis, every time you do your analysis, you will have an accurate data. That's the most important thing as a technician, as a laboratory professional. No? You should always give accurate results. Can you imagine if you are, let's say, a technician in the lab for COVID-19 detection, and then your machine is not doing good, your machines are not accurate, and then you say that the person is infected when in fact the person is not? Can you imagine how much trouble that will give to the patient? Huh? So those are the things that you have to always consider and you have to always avoid. And you can do that when you do these steps. Question? Question? Wala? I have a meeting at 2:30, so I guess we need to end here for now. Okay lang ba yun? By next meeting, we will continue on with sampling and sample handling. Huh? Okay.
Opo, sir. Opo, sir.
Opo, sir.
Once we finish all of these slides, then we will go to your ANACHEM proper. Yes, question, go. Anything? Any comment?
Sir, pwede po kami magpa-upload ng PPT po.
Any question? Baka meron pang question? Sorry?
PPT daw po, sir.
Ano yan? Sorry.
PowerPoint po, sir. Kung
Yung
pwede po
PowerPoint?
sir mag-upload. Opo.
Sorry, naputol. Sorry. I-type nyo na lang. Oh yes, yes. I will give it. I will give the PowerPoint to you. Don't worry. Any question pa? Before you go, can you open your camera kung wala kayong question?
Sir, ano po yung reference book na ginamit niyo, sir?
I will also give you the hindi ko nakikita yung mga... Anyway, sige. Let's just take the print screen, okay? Okay, that's it. Thank you very much. Keep posted sa group chat natin, okay?
Opo. Thank you po, sir.
Thank you po, sir.
Thank you po, sir. Thank you po, sir.
You can go now. Thank you.
Thank you, sir. Bye.
Yes, sir.
Bye, sir.